In this video, we're going to be looking at an application of percents called percent increase and percent decrease. The formulas we're going to be using are right here. To find the percent of increase, you take the amount of increase and divide it by the original amount. A similar formula for percent decrease is the amount of decrease divided by the original amount. Still the original amount. So let's give you a good sense of what this means here with some easy numbers, and then we'll look at some more difficult numbers. So let's say you were training for a run or something, and 1 week you ran 20 miles. And the next week you ran 22 miles. So to find the percent of increase in the distance that you ran, you would take the amount that you increased. So how much did you increase there? What was the increase of from week 1 to week 2? So to get this, you simply subtract. And this one we can do in our head. So to find percent increase for this problem, we're going to take the amount of the increase, which is 2, and we're going to divide it by the original amount. In this case, 20, the amount that you started at before your increase. So 2 out of 20 reduces down to 1/10, and hopefully you know that that is 10%. You could write it as a decimal first if you want, and then change it over to a percent. So that's simply what's happening there. Let's look at another example of one you could do in your head. Let's say that 1 week let's say you're trying to eat more vegetables. So one day you only eat 2 servings of vegetables. We'll do it in a day. And then the next day you eat 4 servings. So you increased your amount of servings. What is the percent increase between day 1 and day 2? Well, again, the amount of increase is 2. You increased by 2 servings here. You went from 2 to 4. Divided by the original amount, which was the original number of servings before the increase, which was 2. Now 2 divided by 2 is 1. And what percent is that? Well, just like any other number, to make it a percent, you move the decimal 2 places to the right, so you end up with 100%. When you take something and you double it, it's 100% increase. Okay? It's 100% increase. If let's say you would have increased from 2 servings of vegetables to 3. Can you do that in your head? What would that be? Oh, wrong one. Here we go. If you went from 2 servings to 3. 2 servings to 3 servings. So how much did you increase? 1 out of, what was the original amount? 2. 1/2 is 50%. You went up by half as much as you had started from the beginning. You had 2 servings. If you cut that in half, that's 1 and add it on. So half of 2 is 1. That's 50%. That's where the 50% is coming from, because it's out of the original amount. So those are just some ones you can kind of do in your head. Let's do a percent decrease one in our head to kind of see what that looks like. Let's say we're starting, the price of something is originally $80. Alright, and now it's on sale for $60. So we need to find the percent of decrease. The percent of decrease is the amount that it went down, the amount of decrease. So how much did it go down here? $20. Out of the original amount, which in this case is the 80. So some people say, oh, the original amount is always the big one. No. Or the original amount is always the small one. No, it depends. So don't go by that. Always go by what the starting number was before the increase or decrease. That's your original amount. So in this case, that's 80. So 20 out of 80. We could reduce that fraction. Let's see what goes into both 20 and 80. 20. So we could cancel these zeros out, which is the same as dividing by 10, and then divide both of these by 2, and we end up with 1/4. So hopefully you know what 1/4 is in a percent. If you don't, you could picture it. 1/4 of something would be this much, which is what percent of it? 25%. Okay, so it's a 25% decrease. If something was $80 in the store and it was 25% off, then you would pay $60 for it, and you would save $20 right there. Okay, so that's how percent increase and decrease works. Let's look at some tougher problems that we can't do in our ahead, we're going to pull out the calculator for these. So let's start with this one. I thought this was kind of a funny picture here. This guy that's selling gas must have a pretty good sense of humor. The price of gas has, that should say, increased. Let's fix that. The price of gas has increased from $3.15 to $3.55 in the last 2 months. What is the percent increase in the price of gas? Round the answer to the nearest tenth of a percent. Well, if you think you know how to do this, pause the video and give it a try, and then start the video again and see how you did. Okay, so we're going from $3.15 to $3.55. So this is a percent increase problem. So in order to find our percent of increase, we need to take the amount that we increased. So how much did this go up? To find that, we need to subtract. And you could probably do this in your head. But if you can't, just line up your decimals and go ahead and subtract. That's fine. So that's 40 cents. So it went up 40 cents out of an original price of $3.15. And we could do this longhand, and maybe I should go through how to do that, although this one doesn't come out very nice, I don't think. But to do this with the calculator, we're just going to take 0.4, and remember, a fraction bar means divide, divided by 3.15 equals. Okay, so you can see if we would have done this longhand, it would have been a little messy. Oops, I lost my calculator. So it's 0.12698. I'll just write that part. 0.12698. And we're supposed to round to the nearest tenth of a percent. Tenth of a percent. Not tenth, but tenth of a percent. If we round it to the tenth right here, it's not going to come out right because we need to change it to a percent first. So to do that, we're going to move the decimal 2 places to the right, and then it will be a percent. Okay, so that gives us 12.698%. Now we need to round it to the nearest tenth of a percent, which is right here. So that 6 is either going to stay a 6, or this number after the 6 could possibly round that up to a 7. Remember, if this number after the 6 is 5 or bigger, 5, 6, 7, 8, 9, then it will round that number up. So that 9 is definitely going to round that 6 up to a 7. So after we round, we're going to get 12.7%. So that's the percent increase in the gas price from $3.15 to $3.55. So if you hear on the news the price of gas has gone up 12.7% in the last 2 months or whatever it is, that's what this would look like. This would be a 12.7% increase on these prices. Of course, if the starting price was something different than $3.15, it would be different. But gas is kind of in this ballpark right now. Who knows? Maybe someone will watch this video in 4 years and these prices will seem cheap. I hope not, but it's a possibility. Okay, let's look at a percent decrease problem. Let's get this out of here. And pull in a percent decrease problem. The population at a local community college was 3,425 students in 2008 and 2,914 students in 2010. By what percent did the school population decrease between 2008 and 2010? Round the answer to the nearest tenth of a percent. So the fact that this was between 2008 and 2010, you're not going to use those numbers. Those numbers are not part of this formula. If they ask for an average or something over the 2 years, then we would have to use the 2 years. But we're not going to worry about that. We're just going to worry about our populations. Our population that we started at in 2008 was 3,425, and then it decreased to 2,914 in 2010. So we need to find the percent of decrease, and that's going to equal the amount of decrease over the original amount. To find the amount that it decreased, we're going to subtract these. Now again, I didn't say this at the beginning, but if you think you know how to do this, you might pause the video, try it by yourself, and then start it and see how you did. Oops, so that's 2,914. So we'll subtract those. 1, 1, borrow. So we got 511. So this school lost 511 students out of, what's the original amount? Where do we start in this story? In this story, we started at 3,425 students. All right, let's pull in the calculator. So we're going to do 511 divided by 3,425 equals. So again, we have a big ugly decimal here. 0.149197. 0.149197. Next step, change it into a percent. Move the decimal 2 places. And that turns it to a percent when you move that decimal. So now we have 14.9197%. Now we need to round it to the nearest tenth of a percent, which is right here where this 9 is. So we're going to cut it off right here. It's either going to be 14.9, or the 1 would round this 9 up to a 0, which would in turn round this 14 up to a 15. It would be kind of a domino effect. But that's not going to happen here because 1 is not big enough to round that 9 up. Now you might notice we've got some big numbers over here with this 9 and this 7, but they don't affect the rounding. It's only the number directly to the right of the place that you want to round to that affects whether you're going to round up or not. So we're not going to round up. 1's just not going to do it. Our final answer then is 14.9%. So this school saw a decrease in its student population of 14.9%. If the problem asked us to round it to the nearest percent, then it would be 15%. And, you know, if you listen to the news or read the paper, whatever, you'll see certain times when it's rounded to the nearest percent, but there's also lots of times where it's rounded to the nearest tenth of a percent. Unemployment figures, increase in prices, because they want to measure that tenth of a percent, that it makes a difference. It gives them information they wouldn't otherwise get if they're always rounding to the nearest percent. They may not be able to see subtle changes. So there are plenty of applications where the tenth and even the hundredth of a percent is used. Well, I hope this helps, and these are little formulas that you want to remember in order to be able to solve these problems.